Math shapes the world. Or is it the world shapes math? The cube is a very good example of a platonic solid. There are a total of 5 platonic solids: tetrahedron, octahedron, hexahedron, better known as the cube, icosahedron, and dodecahedron. So what are platonic solids, and why 5? Why not 6, 7? So platonic solids are actually solids that are made up of regular polygons. Regular polygons are polygons with equal sides and equal angles. In this case, a cube is made up of a square. Every side is the same length, and the angle are all at 90 degrees. So in today's activity, you will try to prove why there are only 5 platonic solids. We'll begin with the first proof. Pause the video, carry out the activity. Well, the simplest proof that there are 5 platonic solids is to make use of the angles that meet at the vertex. There are usually a minimum of 3 angles. It could be more. The sum of these angles cannot be 360 degrees, because if it is 360 degrees, the shape will flatten out. And if it flattens out, it cannot be a platonic solid. So carry out the activity, find out what are the possible angles that can make up a platonic solid. Go ahead. Alright, I've actually drawn 3 regular polygons. We have the triangle, 60 degrees each. We have the square, 90 degrees each. And the pentagon, 108 degrees each. What about the next regular polygon, the hexagon? A hexagon has an interior angle of 120 degrees. As mentioned earlier, we need 3 of these polygons to meet. Right? So if 3 times 120 degrees, that makes 360 degrees. As mentioned earlier in the video, if the angle adds up to be 360 degrees, the shape flattens out and we can't make the platonic solid. Right? So pentagon is as far as we can go. Right, so let's work with the shapes that we have now. For triangles, if there are 3 triangles that meet, okay, that will add up to 180 degrees. Alright, 4 triangles meeting will make up 240 degrees. And likewise, 5 triangles meeting will make up 300 degrees. We can't have more than that. 1 more and we get 360 degrees, flattens out. For the square, we try with 3 first. We have 270 degrees. Okay, 1 more, flattens out. For the pentagon, 3 of them would make 324 degrees. We are still below 360 degrees. Okay, so these are the 5 possible combinations of triangles, squares, and pentagons meeting at one point. If there are 3 triangles meeting at one point, we call it the tetrahedron. 4 triangles meeting at one point is called the octahedron. 5 triangles, icosahedron. 3 squares makes the cube or hexahedron. And 3 pentagons make your dodecahedron. So we have proven that there are only 5 possible platonic solids. Let's try to prove it in another way. The other proof actually utilizes Euler's theorem. If you want to know the proof for Euler's theorem, you can refer to the math shower video. Right? Euler's theorem states that the number of faces added with the number of vertices subtract the number of edges will be equals to 2 if it is a platonic solid. Right? So what are faces, edges, and vertices? Okay, let's take this cube for instance. The faces will be the ones that you can see here. Okay, right? The edges, what do we mean by edges, are the lines here, right? Okay, and the vertices will be the corners. Okay, so let's see whether this works. Okay, we have the faces. There's, as you know, a cube has 6 faces, right? We add that with the number of vertices. Okay, there are 1, 2, 3, 4, 5, 6, 7, 8 vertices. Okay, right? So we have 6 plus 8, that makes 14. Okay, we need to subtract that with the number of edges. Okay, for cube, we have 1, 2, 3, 4 over here, 4 going this way, okay, and 4 going sideways. So a total of 12 edges in a cube. Earlier on, okay, when we add the faces with the vertices, we have 14. Subtract away 12, we have 2. So Euler's theorem is true for cube, right? From now on, the calculation will be rather technical, so you need to go to your activity worksheet to carry on the proof for this, right? So carry on with your activity. So you have done 2 proofs. Okay, why there are 5 platonic solids. Okay, one utilizes the meeting point of all the polygons. Okay, the other one utilizes Euler's theorem. But the thing is, you actually use, for instance, let's take a look at the triangle. Earlier you mentioned that the triangle has an angle of 60 degrees, which means that the sum of angles in the triangle is 180 degrees. This actually is called Euclidean geometry. There is another geometry called non-Euclidean geometry, where it states that a triangle, okay, when you sum up all the angles in it, is actually more than 180 degrees. Okay, there's also another one that says it is less than 180 degrees. So the one that says that it is more actually makes use of the fact that the Earth is spherical. So they work on a spherical geometry. So it begs the question that we started earlier. Does math shape the world, or does the world shape math? That is all for me. Let's talk about math.